So yesterday, we were going over the mole and then the mole equation. So just quick review. The mole is a unit of measurement that indicates essentially how many particles of a particular substance might be present in a certain mass of that substance. Okay? So we use the mole like we use a dozen. The mole is a representative number that's always the same, no matter what substance you're dealing with. Okay? Then we went on to look at the mole equation, which is number of moles, N, equals mass in grams divided by molar mass, which is in grams per mole, and we calculate molar mass by adding together the parts of the compound from the periodic table. So this was our simplest example of a mole equation calculation, and we went through it yesterday. I'm just going to run through it really quickly again today so you see and kind of as a quick review here. All right, so this question is asking us to calculate how many moles of something there are. So right away we know we're looking for N. Okay, and as I said yesterday, we want to write down our givens, that is what numbers the question gives us, and what we're looking for, because that helps us to pick our formula, which in this unit is obvious. It's always going to be this one because it's our only formula. Okay. The other thing they tell me is that the material is calcium chloride. With that, I can calculate the molar mass. And I calculate the molar mass by adding together the parts of that compound. How many calcium atoms are in this molecule? Just one. Right? So I take the molar mass or atomic mass of calcium and I write it down, 40.08. And then I add on how many chlorines? 2. Okay? So I look up the atomic mass of chlorine, it's 35.45. Since there are 2 chlorines, I multiply that by 2. And I'll get that the molar mass of this material is 110.98 grams per mole. Okay. Everybody with me so far? Okay, so on a question like this, okay, our last thing is that they told us the mass is 90 grams. This would be our first mark out of 3. Okay, you get 1 mark for writing down the givens and calculating the molar mass. Question wants us to calculate number of moles. This is the formula that will do it. I don't need to manipulate this time because it's already set up to calculate N, so all I have to do is plug in the numbers I have. Okay? Little m is 90 grams. Big M is 110.98 grams per mole. Okay, when I divide those two things, I think it came out to 0.811 yesterday. Okay? And that will be moles, which we abbreviate mole. We're very busy. We don't have time to write the whole word. It's the next, well, hey, we have an abbreviation for at. Right? That's how busy we are. I don't have time to write 2 letters, so I'll write that instead. Okay? Very busy. So mole, M-O-L. Okay? All right. Everybody understand how that one worked? Right? So you would get a mark for your givens, you would get a mark for your calculation, and you would get a mark for your answer. That's the simplest mole equation calculation, so it's only out of 3. Okay? Ones that involve more steps could be worth 4 or even 5. Okay? And we're going to go over those next. Okay? All right, I want you to write this one down. This is the second way that I can ask you a mole equation question. There are only 4 ways that I can ask a mole equation question. We're going to go over all 4. I'll give you a minute to get that written down. So this question says, what is the mass of 4.5 moles of magnesium bromide? So what is it asking me to calculate? N, little m, or big M? Little m. Okay. Asking me to calculate little m, mass in grams. Okay. It tells me that I have 4.5 moles. What part of the mole equation is that? N. And they tell me that the material is magnesium bromide. And now, I indicated this yesterday. If I give you the compound in words, there's kind of this extra step in that I've got to make sure did I get the formula right? Because if I don't get the formula right, I'm not going to calculate the molar mass correctly either. So it's really important to make sure I do my drops and swaps. Okay, this is MgBr2. Okay. So I'm going to take 24.31. Okay, that's my 1 magnesium, plus 79.9, that's bromine, times 2. So we're looking at 184.11 grams per mole. Okay, so that's what I know. I'm being asked to calculate little m. So that's my formula. N equals little m over big M, but right now, n is isolated, or it's solving for n. I need it to solve for little m. So I need to isolate little m, which means I've got to move big M. Okay? How do I move big M over to the other side of the equation? Somebody mumbled it, but it was right. Right, you do the opposite operation. Right now, I am dividing by big M. So, to move it, I do the opposite. I multiply by big M. That'll make big M cancel on the right-hand side. Second rule of algebra, what I do to one side, got to do to the other side. Okay, so I bring that big M over here. And now, I'm solving for little m. So, I would get a mark for my Gibbons, and I would get a mark for my algebra. Okay. Now I've got to plug in my numbers. So big M was 184.11 times N, which the question told me is 4.5. Okay, so I would get a mark for this, probably. Okay, sometimes I do, sometimes I don't. Either it's a manipulation mark or it's the plug-in mark. It's rarely both, but sometimes I'm feeling generous. Okay, so we have that, and then we plug it into our calculator, 184.11 times 4.5. Okay, so I'm going to have 828.5 grams of this material. Okay, so that would be your final mark for your answer. Okay. So, 4-mark question, because it's got that extra step. Okay. All right, questions there on how that one worked? Okay.
Should you always round to the nearest 10?
The nearest 100, because it was 0, I didn't write it. I should, but I didn't. Okay, so let's say, since all of our molar masses are given to us to 2 decimal places, we'll have our answer to 2 decimal places. Okay. All right, any other questions on that? Okay, so the first 2 types of mole equation questions only involve using the mole equation, because we have to solve for n, or we have to solve for little m. We never have to solve for big M because we always calculate it off the periodic table. The last 2 types of mole equation questions involve using Avogadro's number. Okay, that's the one we learned yesterday, 6.02 times 10 to the 23. Because the next 2 types are going to ask us one of 2 things. They're either going to ask us to calculate the number of particles, that's usually molecules, how many molecules of this compound are there in this mass, or it'll say, there's this many molecules of this stuff, calculate the mass. Okay, it's one or the other. You'll either be asked to calculate the number of particles from the mass, or be given the number of particles and asked to calculate the mass instead. Okay, it's one or the other. So they're not really any harder. There's just an extra step involving Avogadro's number that wasn't present in these 2. All right, so write this one down. This one, we're going to be calculating the number of molecules. All right. Still need to do the same thing. Still need to write down our givens. Okay. First thing is, the question's asking me how many molecules. Okay, that's the question. I don't know, and it's what I'm being asked to find. Are in 600 grams. What did they just tell me there? Little m, right? And they tell me that the material is silver nitrate, which will help me calculate molar mass. Okay, Ag is a +1, nitrate is a -1, so that compound is fine the way I have it written. I just need to calculate the molar mass. So silver is 107.87. Okay, there's only one silver, plus how many nitrogens? 1. Okay, so 14.01. Okay, and how many oxygens? 3. Okay, 3 times 16 is 48. Okay, so 107.87 plus 14.01 plus 48. Right, 169.88. Grams per mole. Okay, so they want me to calculate the number of molecules. Right now, I don't have enough information to do that. But I have little m and big M. What can I calculate with those two things? N, right. I can calculate the number of moles. Okay, the mole equation is set up to do that. Okay, so N equals little m over big M. So I'm going to do that because I've got the stuff to do that part. Okay, so I'm going to calculate N by going little m, 600 grams, divided by big M, 169.88 grams per mole. Okay, I have 3.53 moles of this material. Now, this is an important step. When you're doing any type of calculation in science, keep all your decimals until the very end. Don't round off until the very end. When you're writing your final answer, that's when you round. Up until that point, keep all those decimals. Okay? Either hit the M+ button if you've got, on that on your calculator. If you're still using your phone, it's got an M+ button. Okay? Put it in the memory, and then you can recall it with RM later. Okay? Or if you've got the TI, you can just scroll up and grab it. Okay? Whenever you need it, or it's right there and you can punch it in again. It's just important because in a minute we're going to multiply this number by Avogadro's number, which is huge. And rounding off can have a pretty significant effect, okay, when I multiply by a really big number. All right, so I'm keeping all those decimals, but I'm not going to write them all because I'm lazy. Okay? I'm just going to only write a few here on the board. Okay, so 3.53 moles. Okay, that's all well and good. I got the number of moles. That's not what the question wants. The question wants to know the number of molecules. So I know how many moles there are, and I know this number. What does that number tell me? Pardon me?
Molecules.
The number of molecules in, not a gram, in 1 mole. Okay? That's the number of particles in 1 mole. If I have 3.53 moles, how do I figure out how many molecules I have in 3.53 moles with that number? I spoiled it like a minute ago when I said what we were going to do with it. Yeah? Nope. Multiply. Here's what we're going to do. Okay? It's going to be just like this. I have 3 dozen eggs. How many eggs do I have? Don't say 3 dozen. 36. How'd you do that? Okay, what math did you do?
3 times 12.
3 times 12. And why did you do that? Because there's always 12 in a dozen. And I told you I had 3 dozen. So you went 3 times 12. We're doing the same thing here. This is how many molecules are in a mole. And I have this many moles. So if I multiply those two numbers, it'll tell me how many molecules I have. In the same way that going 3 times 12 tells me how many eggs are in 3 dozen. Do you want to follow my reasoning there? Okay, that's why I made such a big deal out of this being like a dozen yesterday. We use it exactly the same way. All right, so I'm going to multiply those two numbers to get the number of molecules. Okay, so number of molecules equals n times, okay, Avogadro's number, which in this case will be 3.53 with all the decimals I kept in my calculator, times 6.02 times 10 to the 23. Now, you're probably thinking, how the heck do I put that number in my calculator? I'm going to show you. Okay. Your calculator may have different ways to do this depending on what kind of calculator you have. Okay? If you have one of the TIs, like any one of the TI models, like the one I'm using here on the board, okay, this is how you do it. All right, I'm going to take that number and I'm going to multiply it by Avogadro's number, which I enclose in brackets. It doesn't matter what kind of calculator you have, Avogadro's number needs to be enclosed in brackets. Okay, 6.02, and then I'm going to hit the second function button and the comma. Above the comma, you'll see 2 capital E's. When I do that, I get 1 capital E, oddly enough, okay, on the screen. That little e stands for times 10 to the power, and then you punch in the power. Okay, so putting in that e means times 10, and then the next number you enter is the power that goes on the 10. What power goes on the 10 here? 23. That's Avogadro's number entered, okay, on the TI. So you put in the base, then you go second comma, and you'll get the e, then 23. Okay? If you have something else, okay, so when I do that, I get this number, 2.12 or 2.13 times 10 to the 24. It says E24. I would write times 10 to the 24 on my paper. Okay? Now, if you have a different kind of calculator, like let's say you've got something like this, okay? You won't have that double E button, but you will have a button that looks like this. You have an EXP button, okay? Pressing that is like making the little e. Okay, so you go in brackets, 6.02, hit the EXP button. Usually the display changes slightly. So if I go 6.02 and then I hit EXP, okay, I get an E there, and then the next number I enter is 23. Okay, and then I close it off in brackets, and it's exactly the same as on the TI. If you don't have an EXP button, then you may actually have an EE button. Okay, then that's the one you would use. If you have a calculator that has anything that doesn't have either of those things, let me know and I'll come over and have a look. Okay? I can't think of any other ways it might have it, but sometimes I get surprised. Okay? If you're using your phone as a calculator, flip it on its side and you get all the scientific, you get the scientific calculator instead, and I think the Apple one has the EXP, right?
It is EE.
It has EE. Okay, so you just hit do brackets, 6.02, EE. 23 and the brackets. Okay? Now, remember, you need to have a real calculator by exam day. I would suggest you probably need it before then to practice using it. All right? Not doing that is like showing up to do your driver's test having never sat behind the wheel of a car. Okay? That's not good. You should learn how to use the calculator before test day Okay? So make sure you have one. All right. Everybody with me on that? Okay, so this would be probably a 4-mark question. You would get a mark for your givens. Okay? You would get a mark for calculating the number of moles. You would get a mark for this step. Okay? The math for calculating the number of molecules, and you would get a mark for your final answer. Okay, there's only one more way I can ask a mole equation question, and it's the opposite of this one. I give you the number of molecules and ask you to calculate the mass. Okay, so we're going to do everything backwards. Okay, like literally, the whole thing would be backwards. Okay. All right, write that one down, and then we'll walk through how to do it. Okay, so same as before, write down our givens. Okay? The first thing we're told is we're looking for the mass. What is the mass? So I know that in the end, I've got to come up with little a. Okay? The next thing they tell me is the number of molecules. Okay? And it's 1.54 times 10 to the 25. Okay? Is that more than a mole? It's a lot more than a mole. Okay? A mole is times 10 to the 23. Okay? This is on a factor of like almost 100 times or more than 100 times bigger. Okay? All right. And so it's of diphosphorus tetraiodide. So they told me the stuff. Diphosphorus, P2, tetraiodide, I4. Should I reduce that? No. I would reduce it if it was ionic, but it's molecular. Okay? If I got prefixes that tell me the numbers are 2 and 4, the numbers are 2 and 4. Okay? If I arrive at a 2 and a 4 by a drop and swap, then I reduce. Okay. So phosphorus, 30.97, right? Is that right? Okay. So 30.97 times 2. I always get that in sulfur mixed up. Okay, and then I've got iodine, and I've got 4 of those, and it's 170. No, 126 point. And there's 4, so times 4. Okay, so this stuff's heavy. 569.54 grams per mole. Okay, I have big M, that's nice. And I have the number of molecules. That's nice. I need to find M, little m. If I'm going to get little m, I need this, I got that, but I also need n, and I don't got that. How am I going to get it?
Molecules divided by molar mass.
Not by molar mass, but by
Avogadro's number.
Avogadro's number, right? Avogadro's number. Okay, because that's the opposite of what we did in the last question, right? To find the number of molecules, we took n and multiplied by Avogadro's number. We got number of molecules. If I take the number of molecules and divide by Avogadro's number, I'll get the number of moles. Comparison. I have 48 donuts. I'm going to get real fat. Okay, I have 48 donuts. How many dozen do I have? 4. How'd you do that? 48 divided by 12, right? You took the number you had, you divided by the number in a dozen, and it told you how many dozen you had. I'm doing the same thing here. I'm taking the number of molecules, this big number, and I'm dividing that by Avogadro's number, because that's the number of molecules in 1 mole. Just like 12 is the number in a dozen. Okay, so I'm going to calculate n by going, okay, number of molecules divided by Avi guy's number. I like that. I'm going to keep using that. Avi guy's number. Okay. All right. So that's going to be 1.54 times 10 to the 25 divided by 6.02 times 10 to the 23. Okay. So both of those numbers have to be enclosed in brackets on my calculator. So 1.54 E25 divided by 6.02 E23. Okay, it should look like that before I hit enter. All right, 25.58 moles. So that's a lot. Okay, now I have N and big M. Can I calculate mass? Yes, but I have to manipulate first. This is set up to calculate number of moles, and I needed to calculate that, so what do I do with M? Right, multiply it over to the other side. All right, so now, little m equals 25.58, the number of moles, times the molar mass, which was 569.54. So this one's got, a fair number of steps in it. That's why it would be worth 5 marks. Okay, so I'm taking that and I'm multiplying by that. Okay, I have 14,569.63 grams, or 14.5 kilograms worth of this stuff. That's a lot. Okay? 14,569.63. So we really only ever do 3 calculations. Calculate molar mass, which we always do the same. Do a mole equation calculation, which either calculates N or little m. And use Avogadro's number to either figure out number of molecules or number of moles. Okay? Those are the only 3 calculations we ever do. All right, so marks-wise for this question, you would get a mark for your givens, same as always. Right? You would get a mark for figuring out the number of moles. You would get a mark for your algebra in manipulating the mole equation. You would get a mark for plugging the numbers into the mole equation, and a mark for your final answer, 5. Okay? All right. Those are the only 4 ways I can ask you a mole equation question. And now I've shown you how to do all 4. And I'm going to do that every day for the rest of the unit. So every day you're going to get new examples of how to do the mole equation questions. Okay? And then on your unit exam, I'm going to ask all 4 ways. Okay, so here's what I want you to do. Exactly the same order that we just did them in. Okay? 3 different ones. 4, this many. 4 new ones. I do 4 new ones, and they're exactly the same as what we did before. I just picked different compounds and different masses. All right? So I'll give you some time to get ahead of me here, and then we'll walk through them one at a time. So for our first one here, we're being asked to calculate how many moles. So we're looking for N. They tell us the material is carbon dioxide, CO2, which means 12.01 plus 16 times 2, so 3244.01 grams per mole. Okay, and they tell us the mass is 150 grams. Okay, so we have big M and we have little m, and we're looking for N. Okay, so N equals little m mass over big M molar mass. All we have to do is plug in our numbers. 150 on the top, divided by 44.01 on the bottom, and that'll get us our number of moles. All right, so we're looking at 3.41 moles. Okay, questions on the first one? How many people are ready to do the second? Okay, let's look at the second. Okay, so in this one, we're being asked to calculate the mass. It says, what is the mass? So we're looking for a little m. Of 26.5 moles, so they just gave me N, of cobalt-2 bromide. So that'll help me calculate big M. Cobalt is CO. The Roman numeral tells me this is the CO with the 2+ charge, and it's with bromine, okay, which is a -1. So when I drop and swap, I get COBr2. I don't remember what the mass of cobalt is. 58.93. Okay, plus 2 bromines, so 79.9 times 2. Okay, 218.73 grams per mole. Okay, so I've got N, I've got big M, and I'm looking for little m. Okay, how do I get little m by itself?
You multiply both sides by molar mass.
Right, multiply both sides by molar mass. Okay, now I'm solving for m. All I have to do, or little m, sorry. Now I'm just plugging in my numbers. Okay, so that's going to be 218.73 times n, which was 26.5. All right, so we have 5,796.35. What are my units? Calculating mass, so my units should be grams. Okay. All right, I'll give you a little bit more time to get ahead of me again on 3 and 4. Okay. Oh, to the first question. Okay, sorry. Okay, so on number 3, we're looking for how many molecules of sodium sulfide are in 29 grams. So we know we're looking for the number of molecules. Okay, we're told the mass, and we're told the material. What do I have to do with that? Drop and swap it, right? This is a -2, that's a +1, so we're looking at Na2S here. Okay, so that's going to be 22.99 plus 32.06. 7.07. Okay, and there's only one of that, so that should be times 2 there. Okay, so 22.99 times 2 plus 32.07. All right, 78.05 grams per mole. Okay, so I've got little m, I've got big M. What can I calculate with little m and big M? Number of moles. Okay, I can calculate N, and that is what I should calculate first, as it right now is the only thing I can calculate. All right, so little m, we were told was 29 grams. We're dividing that by big M, which we just calculated to be 78.05. All right, We have 0.37 moles. Okay, so now I know N, but I need to calculate the number of molecules. I also know this number, Abigai's number. Okay, and it is the number of molecules in 1 mole. Okay, I have 0.37 moles. And I want to calculate how many molecules I have. What do I do with that 0.37 and Abigai's number? I what? I multiply them, exactly. Okay, so to get the number of molecules, okay, so that's going to equal 0.37 times 6.02 times 10 to the 23. So in my calculator, that's going to look like this. I'm going to take that number and I'm going to multiply it by, in brackets, 6.02 second E 23. End bracket. All right, so I have 2.24 times 10 to the 23 molecules. Questions on that one? I'll give you a few more minutes on number 4. let's look at number 4. So in number 4, we're looking for the mass. So we're looking for little m. Okay. We know that there are 7.2 times 10 to the 23 molecules. Okay, and we know that the material is diphosphorus pentaoxide. So P2O5. So that can help me get the molar mass. So we got 30.98, right? 97. Okay. Times 2 plus 16 times 5. All right, so we're looking at 141.94 grams per mole. Okay. All right. If I'm going to get m, little m, I need the number of moles. I need n. And I can get that because I have the number of molecules and I know the number of molecules in 1 mole. What do I do with those two numbers to get n? I know how many I have, I know how many are in 1 mole, and I'm looking for number of moles. What do I do with those two numbers?
Would you divide it by, would you divide the molar mass by the number?
Not the molar mass, I'm going to divide, but I'm going to divide
Molecule.
the number of molecules by Avogadro's number. Okay, remember, this is when I asked you, I have 48 donuts. How many dozen do I have? You went 48 divided by 12. I'm doing the same thing here. I'm taking the number of molecules and dividing by the number of molecules in 1 mole. Okay, that will get me the number of moles. Okay, so n is going to equal 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. So I'm going to have just over 1 mole. Okay? And if you know anything about math, there's a bit of a shortcut here. Because these both have the same exponent, I can just divide the bases. Okay? If they have the same exponent, you can do that. If they don't have the same exponent, you can't. Okay? So 7.2 divided by 6.02. Okay, so 1.196 moles. All right, now I have n and I have big M. So now I can calculate little m. I can calculate the mass. So n equals little m over big M. I've got to isolate little m, so I'm going to multiply by big M, multiply the other side by big M. Now I've got my formula. Okay, so 141.94, big M, times n, which was 1.196 moles, will give me my mass. Okay, so I'm going to have 169.76 grams.
When I got like the 1.196,
Yep.
I rounded it to 1.2, and then for little m I got 170.
Right.
I still get that right.
No, that's why you want to keep all of your decimals until the end. Don't round off until that very last step. Okay? Especially when we're dealing with big numbers like 10 to the 23. Like we have to make sure we don't round off till the very end. Okay? And it's going to be like that in all of your science courses, chemistry, physics, biology. When you do calculations, always keep your decimals until the end. Okay? All right, how are we feeling about that stuff? Okay? I mean, it's going to take some practice. This is really only our first day, okay, doing the calculations, so it's okay if right now it feels a little bit overwhelming. Okay. All right, let's take about a 3-minute break here, and then I'm going to talk about the labs just a little bit. All right, let's quickly look at number 4 here. So on number 4, they're telling me how many molecules I have, and it just happens to be exactly what compared to Avogadro's numbers? Exactly 1/2, which means I have exactly 1/2 of a mole of copper. okay? Sometimes you just get lucky like that and you don't have to do as much calculating. I can just recognize that this is exactly 1/2 of Avogadro's number, and thus N is 0.5 moles. Save me some calculators, okay? I know that it's copper, okay? So big M is going to be the molar mass of, or the atomic mass of copper, which is 63.55. Okay, and I'm looking for the mass. So I've got to manipulate for little m, which is always the same manipulation. Okay, I just multiply both sides by big M, which simply means 63.55 times 0.5. All right, so 31.78 grams. All right, everybody okay with that one? All right, how are we doing on number 5? How many people have done 5? Okay, give you another minute or two and we'll look at 5. All right, if I'm looking for the number of molecules, okay, I'm going to need the number of moles, okay, and Avogadro's number, because I'm going to multiply those two numbers together. So if I'm going to get N, the number of moles, I'm going to take the mass, 1,000 grams, that was told to me in the question, and divide it by the molar mass. For water, that's 18.02 grams per mole. Okay, so if I go 1,000 divided by that, okay, I get that I've got 55.5 moles of water, and then I simply multiply that by Avogadro's number. Okay, and I should get 3.34 times 10 to the 25 molecules. Okay. All right, we're going to be working some more on that tomorrow. And then Friday we'll do our unit exam review. Talk about what's going to be on the unit exam, basically lay it right out for you so you know exactly what to study over the weekend. And I'll give you a unit exam review package, okay, some extra things to try to do to study. Okay, it will include a practice test, which I would highly advise doing because it's very much like the real test. The test is next week, and it is on the 16th, so that's Wednesday. All right? Okay.